Welcome to a chemistry video tutorial that will cover binary covalent compounds and diatomic molecules and their nomenclature. Let's get started. Alrighty, now what exactly is a diatomic molecule? Well, it's a compound containing two identical elements, right? So remembering elements are unique. We can have more, I think just stop there, all right? So that's all it is. Now there's a very simple phrase that can help us know and memorize the diatomic molecules. Have no fear of ice cold beer. All right? So how does that help us? All right? Well, if we look at the first letter of our phrase, it will let us know which elements exist as diatomic molecules. Hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. So, whenever you read these element names, you need to visualize the diatomic molecular formula. For example, when we say we breathe oxygen, it's diatomic oxygen. All right? Now, we've already learned some ion names, so we need to keep everything straight, right? So if we refer to hydrogen, we're referring to H2. Another important example here would be a hydrogen ion, right? So if we're talking about a hydrogen ion, then of course that would be H+, or hydride is with the H-, right? Nitrogen, the diatomic molecule, versus nitride, right? So it's all in the suffixes. So if we look at the suffixes here, they are for the element names. And so in a scientific context, whenever we use these element names, we now know they exist as these diatomic molecules. If we wanted to talk about a hydrogen atom all by itself, that would be atomic hydrogen. All right, and then of course on the right here we see the ions, and then we have the suffix change, those ides, right? And these are all monatomic ions. I'd rather be alone. I'd rather be away from oxygen. So the ides let us know that those are the ions. So linguistically, there's a lot of information nested in the suffixes. So we've got to pay attention. And then to practice that, right, so here's some examples, right? So when we see this, this is the ion chloride. And then when we read the word chlorine, have no fear of ice-cold beer. Here we have the ion nitride. And when we read the word nitrogen, we recognize that it's part of the have no fear of ice-cold beer gang. Okay, so let's go to, and that's really all there is for diatomic molecules. Just make sure that you know the 7, so you want to memorize that. The next 2 pages will be for the binary covalent compounds. So before we get into those, let's reflect on what we know about nomenclature so far, right? So for ionic compounds, it's always a fixed ratio because the charge of the ions have to balance out to create the neutral compound. So for example, if we read the name iron 3 hydroxide, this is a perfectly good name. This is all we need to know to figure out the chemical formula. Because when we read this, we see that the Roman numeral is telling us the charge on the iron 3+. And then, of course, we have hydroxide, one of the ions we've memorized, and we know it's a -1. So there's only one possible way for these two ions to come together to create a neutral compound, since we're always going to use the smallest ratio. So we would describe this as the formula unit for the ionic compound. And, you know, and this is like the iron is losing, and the hydroxide is taking, and so when we're in a give and take situation, there's often not a lot of options. But when we get to covalent compounds, right, these nonmetals can come together in a variety of ways because they're sharing. They're not gaining or losing. And if we look at our own life, when we have a spirit of sharing, there's a lot more options out there. So the same thing's true of atoms and molecules. So, for example, anyone that's ever had their car smogged, if you looked at the smog report, there was a category for NOx emissions. So NOx represents the binary covalent compounds composed of nitrogen and oxygen that can exist in our car exhaust. And we can see that there's a ton of different possibilities. So when we look at this binary covalent, now we have two different elements. So the binary is referring to the number of elements present. Notice here that there's definitely more than two atoms, right? Atoms versus elements, but there's only two elements present. So now we will look at how we would name binary covalent compounds, because we see that the Ionic compound rules aren't going to work. So that's why we have to have some new nomenclature rules, and we're going to use the Greek prefixes. So in the way that for Ionic compounds, those Roman numerals were a big deal, very international, this nomenclature, right? The Greek prefixes are going to be the key for the binary covalent compounds. So we've got a little more to memorize, right? So these Greek prefixes, they should be pretty straightforward. I don't think they're a hard thing to memorize, right? Mono, of course, would be 1, and di is 2, and we all had tricycles, hopefully, when we were little, tri. And then tetra, that's 4 for the tetrahedron, right? Penta, the pentagon, hexagons, 6, hept, 7, oct, 8, octet rule, nona, 9, deca, 10. All right, so you really want to get these Greek prefixes memorized right away, and there will be benefits as we move on to organic chemistry, because many of these prefixes will be used again for another nomenclature series that we'll be learning in the future. So it's a good investment of your time. So overall, for naming binary covalent compounds, we have a generic structure. There's a Greek prefix that possibly precedes the first element. We'll look closer at that on the next page. And notice that it gets the full nonmetal name. All right, so this is all for the first element. And then for the second element, it will always have a Greek prefix. And then we'll have the stem, but notice we're going to switch to "-ide" for the second element. All right, so very straightforward. Still two parts, right? Since it's binary, there's only two elements present. So the first element listed will get its full name, and the second element will take on the "-ide" suffix. So let's practice that on the next page. Alrighty, so here are the rules that I mentioned, all right? So we named the first element using the prefix to indicate the number of atoms. However, look down here at Rule 3. We do not use the mono prefix for the first element, okay? And we'll do an example of that very soon, all right? And then we name the second element, right? And we use the "-ide" suffix like we talked about already. And one last thing, when we look at those Greek prefixes, if the Greek prefix ended in an A, and we're going to use it with oxygen or oxide, right? We're going to remove it. And I'll show you an example of that as well. All right? So let's look at these examples to illustrate how we apply these rules. All right? So nitrogen is the first element, so it gets its full nonmetal name, and there's two of them. So this would be dinitrogen. Okay, now we look at the second element. Might as well color code here. Okay, so now 5, right? So 5 would be penta, right? But we're going to have oxide, so we're going to drop the A. So then that would be pent oxide. So the full name of this compound is dinitrogen pentoxide. All right, so that really emphasizes rules 1, 2, and 4. All right, now let's look at an example that utilizes, also uses rule 3. All right, so here we have our bromine, right, and it's listed first, so it gets its full name, and there's only one of them, but since it's the first element, we omit the mono, so it's simply bromine. Now, for the fluoride, right, so it gets the suffix, and there's one of those, so mono fluoride. Okay, so in both examples, the first element listed gets its full nonmetal name. We use the Greek prefix if it's not a mono. For the second element, we always end it with the "-ide suffix, and we're always going to include the Greek prefix. All right, so now we're starting to have quite a bit of nomenclature that we're responsible for. So here's a table. This would be a good time to pause the video to double check and see how you're doing, and then I will give you the answers. All right, welcome back. Hopefully you paused and took a moment, right? So when we see O2, we recognize that as oxygen. That's the oxygen we breathe, because oxygen is part of the have no fear of ice cold beer gang. Oxide, the suffix lets us know O2 minus. All right, now here we have, right, nitrogen. There's only one of them, so we skip the mono. All right, now this oxygen is not a diatomic molecule, right? A diatomic molecule just means we have 2 oxygen atoms. These 2 oxygen atoms are part of a binary covalent compound. So in this circumstance, we would be dioxide. All right, and then last but not least, right, chromium 3, remember, this is the cation name. So this is telling us we have chromium with a +3 charge. And then there's our buddy oxide again. And so then we're going to find the smallest ratio of whole numbers to give a neutral. So we would need 2 chromiums and 3 oxides. So that this would be the chemical formula for chromium 3 oxide, because the Roman numeral is giving us the charge. All righty. Well, that concludes this video on binary compounds and diatomic molecule nomenclature. It's always a good idea to have a few more practice problems to reinforce your understanding.